as squared plus bs is equal to 0. To see the sign for it, first of all, we take the roots. The roots of it are s1 and s2. And then we say s vary from minus infinity to plus infinity. And if we have a polynomial like this, as squared plus bs plus c, the sign here, it will be from minus infinity to s1, it will be same sign as a, coefficient a here. And here, same sign as a also. But inside the interval between s1 and s2, it will be opposite to sign of a. This is what we did here, Shabab. Here we did sign plus positive, exactly as the sign of a, which is 3. And then inside it is opposite. And then we have seen the condition that is satisfied everywhere, which is here and here. So another example, this is the way how to find the route stability without solving the characteristic equation. We are able to say that the system is stable or not stable. You don't need to solve. Nowadays also, if you have an equation, ready equation, which has no parameter, explicit equation, it has no parameter like k here, you can solve it using MATLAB. And if you see that you have a positive real roots, it means that the system is not stable. We have some special cases, Shabab, a 0 coefficient in the first column of the row array. If we have this situation, when the first term is in a row is 0, the following element of power minus 1s will be infinite. Then we will be dividing by 0. One of the following method may be used. We use method 1, just substitute s is equal to 1 over x, and then we solve for x normally. The second method is to multiply the original equation by s plus a, and then we solve normally. And the last method, which is we substitute just small parameter epsilon for the 0, and then we complete the array and take the limit when epsilon goes to 0. So the situation will be like this. If we have an example like this one, check whether the following system given by its characteristic equation is stable or not. We have s to the power 4 plus s cubed plus 2s squared plus 2s plus 5 is equal to 0. We construct the rows array, s to the power 4, and then s cubed, s squared, s to the power 1, and s to the power 0. We take the coefficient of s to the power 4, 1, here 1, and then we jump, next one will be 2, and then we jump, next one will be 5. For s cubed, we have 1. We jump the 2, we will get 2 here, and then we will have 0. To calculate the arrow here, 1 multiplied by 2 minus 1 multiplied by 2 by 1 will be 0. So next here, we are going to divide by 0. We are going to divide by 0, and this one will give us infinity. So this is a problem here. 0 element in the first column. We can't continue as usual because here now if we calculate this one, it will give you some number divided by 0. This is infinity. So what we do, we just, this 0, we replace this 0 by epsilon, where epsilon is small number. There are 3 methods of this one, Shabab, but I will give you the simplest one. I need the shortest and simplest one, which is method number 3 here. So we substitute the 0 by epsilon, and then we will say, next one will be 2 multiplied by epsilon. Here, we are calculating here. This will be 2 multiplied by epsilon, minus 1 multiplied by 5 divided by epsilon. So 2 times epsilon minus 5 times 1 divided by epsilon. Or you simplify 2 by epsilon, this will give you 2 minus 5 over epsilon. And when you take the limit of epsilon, when epsilon goes to 0, this is minus infinity. Okay, Shabab? Now, here you have 2 minus 5 minus epsilon, multiply by 2, minus 0, multiply by epsilon, this will give you 5. So what is important for us is the sign. The sign here. We have minus, we have positive, and then negative, and then positive. First sign change from s to the power 2 to s1, and the second sign change is from s1 to s to the power 0. So we have 2 sign change. This means that we have 2 roots. that lie on the right-hand side of the S-plane. So the system is unstable. واضح شباب؟ Any question? Any question شباب؟ تفضل هاني.
Doctor, even if we have only one sign change, we will have unstable system, right?
Yeah, of course. Yeah. لا, we have two sign change. مستحيل يكون one sign change. Impossible.
From positive just negative.
إيه بس وبعدين we have to
yeah,
go to
and then negative.
لا. It doesn't
cannot
happen
be.
for physical
Okay.
system. For physical system, it doesn't happen. This is always the case. We have two sign change.
Okay, thank you.
Any questions, Shabab? So this is the Shabab. If you plot this, or if you just say Q, this is your Q. في MATLAB, this is Q. And then say roots of Q, you get this one. This guy, 0.573, 0.573, they are troublemaker. They are troublemaker because they are having a real value, which is this one, located at the right-hand side plane. This is the real axis. This is the imaginary axis. And they are located in the right-hand side plane. So they make the system unstable. واضح شباب? Or you can do the PZ map plot. The PZ map plot, it shows here that you have two poles located here. Another case, شباب, rows of zero. ممكن sometimes we get a row of zero. Zero هنا and zero هنا, row of zero. This happen when we have the poles are يعني symmetric with respect to the origin. And you have this pole is symmetric with this pole. Or this pole is symmetric with this pole. Or this pole is symmetric with this pole. Or this pole is symmetric with this pole. With the symmetry is with respect to the origin. When we have this situation, we will see how to handle this one. So we construct the auxiliary equation. Just follow me, and then next slide I will show you how to do that. We will form the auxiliary equation. What is the auxiliary equation? Is this one. هنا شباب, we got this example s to the power 5 plus 5s to the power 4 plus 11s cubed plus 23s squared plus 28s plus 12 is equal to 0. When we construct the rows array, this is 1, 5, s to the power 5 is 1, and then 11, and then 28, and then if you want 0. This is 1, 11, 28. For s to the power 4, we'll have 5 and then 23 and then 12. 5, 23, and then 12. We construct this one. Normally, 5 times 11 minus 1 times 23 over 5. We get 6.4. And then this one here will be 5 times 28 minus 1 times 12 divided by 5. We will get this. And then we construct the next one. Next one will be 6.4 times 23 minus 5 times 25.6 divided by 6.4. This will give you 3. And similarly, we can find this one. But the next one, which is this one here, this will give you 3 times 25.6, 3 times 25.6, which is this one, 3 times 25.6, minus 12 times, I am lost here, Shabab. 3 times 25.6 minus 25.6 multiply by 5. Is that right? No, this is okay, fine. Here, Shabab, we are here. 3 times 25.6 minus 6.4 times 12, this one. This will give you 0. And then here also, this will give you 0 because you will have 3 times 0 minus 6.4 multiplied by 0 divided by 3. This will give you 0. So this is the row of zeros. What we do here, we got a row of zeros here. 1 0 is at the first row, and the other 0 is at the first column, and the other 0 is at the second column. So this is the row of zeros. We construct the auxiliary equation. How to get the auxiliary equation? The auxiliary equation is the row before the row of zeros. So this is the row before of the row of zeros. Row I'm writing it هنا. Row of zeros, the auxiliary equation, which is the row before row of zeros. This one. This means this is 3s squared plus 12, and we are at s squared, and we are jumping powers. So this will give you 3s squared plus 12. 3s squared plus 12. What to do now, Shabab? We just differentiate this with respect to s, das over ds, and then substitute this 0, substitute the coefficient by 6, and then continue normally. I will read what was here before. So from the auxiliary equation E of S, by use of the coefficient from the row just preceding the row of zeros. Step 1, take the derivative of the auxiliary equation das over ds with respect to s. Now replace the row of zeros with the coefficient of das over ds. Continue the Routh tabulation in the usual manner with the newly formed coefficient in the rows of zeros. Interpret the change of sign, if any. So this is what we did. We got a row of zeros is here. We replaced, we took the auxiliary equation, 3s squared plus 12, which is this one. We differentiated, we got 6. So this guy 0 here will be replaced by 6, and you will see how did we replace it for next slide. So I replaced this one by 6 here. And now the next one, this is the replacement from the auxiliary equation. The replacement is this one. Now we will get this times this times 12 minus 3 times 0 divided by 6. This will give you 6. Positive, 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 positive. So the system is stable. There are no sign change. There are no sign change هنا. شباب هنا the auxiliary equation بس تعقيب على auxiliary equation في multiple choice question that is coming for final exam. It says roots of the auxiliary equation are also roots of the characteristic equation. We will see هل هذا صحيح ولا لا. So it means we will solve this equation. We will solve 3s squared plus 12 is equal to 0. We'll solve it. If you take 3 barra, you will have s squared plus 4 is equal to 0, and you will find s is equal plus or minus j2. What does this mean? S is equal plus or minus j2. It means that your system is marginally stable لأنه البول is pure imaginary, and the frequency of oscillation is 2 radian per second. Now this is the roots of the auxiliary equation are from here. S is equal plus or minus j2. And if you solve the characteristic equation al-asliya, the big one, the large one, you get these roots. Minus 3, minus j2, plus j2, minus 1, minus 1. If you look here, these two poles, plus or minus j2, are contained here. So this is why we are saying roots of the auxiliary equation are also roots of the characteristic equation. Remember, roots of the auxiliary equation are also roots of the characteristic equation. هل العكس صحيح? Is the opposite true? Faris Zahrani, can you answer my question? Is the opposite true? يعني هل roots of the characteristic equation are also roots of the characteristic of the auxiliary equation? هل العكس صحيح? Faris Zahrani, can you answer my question, please?
I think yes.
Muhammad al-Rushudi, can you ask my question, please? And I will ask student. And I will ask. Muhammad al-Rushudi.
Sorry, Doctor.
Is it true?
والله ما أتوقع ما أدري صراحة.
طيب. علي الشهري, do you think that roots of the characteristic equation are also roots of the auxiliary equation?
No, I don't think so.
طيب. لأنه ليش it's clear هنا شباب. these two poles are included here. That's why we are saying roots of the auxiliary equation are included in the characteristic equation. But the opposite is not true. Yani the roots of the characteristic equation are not necessarily roots of the auxiliary equation. And you have -3, -1, and -1 are not here. So العكس مو صحيح، مو دايما صحيح. So remember this شباب. So the auxiliary equation, how to form it. Some limitation بالنسبة لهذه route stability. شباب, this is relative stability and it does not tell us about when we have cosine term or sine term or any other characteristic. Another example here, just to finalize this one. Example, determine the range of K so that the system is marginally stable and find the frequency of oscillation if applicable. S to the power 4 plus K S cubed plus 2S squared plus K plus 1S plus 10 is equal to 0. If we construct the rows array here, we will end up by, this is the coefficient of S to the power 4, and then we jump 1, we will have 2, and then we jump 1, we will have 10, and then we go to the power 3, we have K, and then we jump 1, we will have K plus 1, and then we will have 0. And then here, shabab, how to construct? I'm saying in a B3, and then 10, and C3, and then D3. How to find B3? B3 will be K times 2 minus K plus 1 times 1 divided by K. So at the end of the day, B3 will be this one, and C3 will be K minus 1 multiplied by K plus 1, here, this one, divided by K minus 10 times K over this one, K minus 1 over K. So at the end of the day, we'll get C3 will be minus 9K squared minus 1. And D3, here D3 will be simply C3 multiplied by 10 minus B3 multiplied by 0 divided by C3, you will get 10. So the most important thing are B3 and C3. I'm reporting them here. First of all, we have S to the power cubed. S to the power cubed gave us K. From S to the power cubed, we have K. This is condition, and K must be positive. And then S to the power 2 give us B3 or give us K minus 1 over K. This must be positive also. If we say K minus 1 over K, this means K must be positive. And then the last one will give us, C3 will give us minus 9K squared minus 1 over K minus 1 must be positive. So هنا شباب, if K is greater than 1, it means معناته automatically K is greater than 0. Is that right? Let's take حبة حبة. This is 1, this is 2, and this is the condition 3 هنا. If K is greater than 1, it means automatically it's greater than 0, صح؟ So معناته this condition تلغي هذه. أو كيف كنا نقول شباب في القرآن تمسخ النسخ، هذه تنسخ هذه.
Yes.
So هذه تنسخ هذه. So هذه this condition تنسخ هذه. ما دام K is greater than 1 معناته automatically this is greater than 0. بس هذه condition هنا, this will give you minus. You can write it like this, minus 9K squared plus 1. This condition قدامها minus 9K squared plus 1. This gentleman 9K squared plus 1 is always positive. مهما يكون value تاع K, you square it, you plus, you multiply by 9, you add 1 to it, it will be always positive. مسبوقة بإشارة minus معناته this, the whole term will be always negative. مهما يكون K. So the system is unstable. مهما تكون الفاليو تاع K, the system is always unstable. لأنه you will have a sign change هنا. في C3, في C3 you will have a sign change. So this will give you from positive to negative and from negative to positive. So always you will have two sign change. This is the first sign change, and this is the second sign change. From positive to negative, and then from negative to positive. So the system will be always unstable. واضح شباب? Any question? لأنه هذا this guy هنا always positive. مسبوق بإشارة minus, so it will be always negative. واضح شباب? Any question? Any question?
clear.
طيب شباب شكرا جزاكم الله خير. So now شباب, since we have this parameter playing هنا around ومنا, the next topic will be what will be if the value of k is changing, how the roots are varying within the within شباب the S-plane, within the S-plane, how the roots are varying or are playing, which is here we can call it the root locus. We can call it the root locus, يعني when the value of k is varying, what will be the change of the roots. مثلا هنا we have the S-plane, we have here the real part, we have the imaginary part, and the poles, they can play, they can do this. They can do this. If they are playing like this, so the system will be stable. We will have a full picture of the roots, how they are playing, which is the last topic we are going to cover here in this course. So here the closed loop poles and zero, it's well known, you know it here. So usually we can write it in this form. Feedback, Gs over K of S. And then we have G of S can be written as numerator over denominator when the degree of numerator is less than the degree of the denominator. So the closed loop system here, G of S or C of S over R of S, we can write it like this. J over 1 plus K G of S, when K here is a parameter that we are playing to see how this one will vary when K vary from 0 to infinity. So the closed loop, the characteristic equation will be like this. D plus K times N of S will be equal to 0 when we do this performance. So the root locus can be plotted in the complex plane as a function of K is called the root locus. K vary from 0 to infinity. If K is equal to 0, we will have D of S is equal to 0. So the root locus start at the pole of G of S. Then when D of S is equal to 0, the denominator, we will have K equal to 0 also. So the root locus start at the pole of G of S, roots of D of S. Notice we can also put this equation, we can put it, we divide by K, and we will have 1 over K D of S plus N of S is equal to 0. And we can see as K goes to infinity, what will happen to N of S? N of S will be 0. So the root locus ends at the 0 of G of S. So these are some values here. And we can, the characteristic equation of the closed loop transfer function will be simply 1 plus K G of S H of S here. You know, this is a parameter. You can consider it as a parameter that vary with us. And we have the closed loop transfer function like this one. So the essential means that we need to plot this equation. How to plot this equation? Through an example, I will show you a small example. If we have a situation like this, unity feedback, G of S is given by this, and we have K here. If we closed loop characteristic equation will be 1 plus K G of S H of S, or 1 plus K S times S plus 2 will give you S squared plus 2S plus K. If we solve this equation, Shabab, if we solve it, it will be in terms of K. Of course, the K here is a parameter. So S12, the poles will be -1 plus or minus 1 minus K. Yani S1 will be -1 minus 1 minus K. And then S2 will be, S2 here will be -1 plus or minus K. This is very easy how to solve it. Now we will see how this S will vary by varying these two poles. واضح شباب هنا what we have this equation and this is what we get. This is our equation. S1 will be -1 minus 1 over K, and then we change the value of K. If K is equal to 0, شباب, if K is equal to 0, what will be S1 هنا? S1 will be -1 and -1, صح? Will be -2. We are taking K is equal to 0. What will be S2, شباب? S2 will be equal to -1 plus 1 will be equal to what? 0. So minus 2 and 0 will be هنا شباب real part when k is equal to 0. This one we have S1 is equal to minus 2 and S2 will be equal to 0. صح? And then let's take k is equal to 1. K is equal to 1. K is equal to 1. What will be S1 شباب? It will be minus 1 صح? And S2 will be equal to what? Minus 1. الجماعة هذو يتلاقوا تتذكروا شباب قلنا هذا جاي on this guy from this way. This one is going this way. This guy is going this way. هنا يتلاقوا. لقاء. بعد اللقاء what will happen؟ لأنه فيه بزمن الكورونا ما راح نقول عناق. بعد اللقاء لا فيه كورونا لا عناق ففراق. say hi من بعيد say hi. أو السلام عليكم. So شباب this guy will come this way. This guy لازم تباعد اجتماعي لازم وإلا راح تدفع غرامة. So شباب هنا they will meet at this point and then one of them goes this way, the other one goes this way, like this. So the pole here, you see this is the imaginary part and this is the real part. The poles are located only in this region. They will do this. So the system is stable for all values of k. Except for the values of k is equal to 0, it will lie on the imaginary axis. And this هنا غيرنا احنا الفاليوز غيرنا minus 2 k is equal to 0 0.5 1 1.5 2 2.5. The values of k is changing هنا and the values of S1 are changing هنا and S2 are changing هنا. You see شباب, the amazing thing, they have the same real value negative, real value negative, real value negative, real value negative. So the poles will be lying on this axis. This is يعني صراحة it's ridiculous to do all this and it's time consuming. It's time consuming to draw all these poles. Is there any way to draw these poles طريقة يعني حلوة كذا fancy وممتعة? Yes, there is one طريقة ممتعة وحلوة. Is this clear شباب؟ سلطان الله يسامحك احنا وش جبنا اكسل؟ هذا اكسل تاع الناس اللي يشتغلوا في الاداره والمحاسبه في زميلنا نسيته بسرعه بالسمستر ما خلص ونسيته صاحبنا الابدي في الكورس هذا ولا ماتيماتيكا ما تكلمنا على ماتيماتيكا
الماتلاب يا دكتور فاين
صح.
روتس
لا بس في طريقه احلى من كذا. كشف فشله فارس الزهراني كتب لي كشف فشله ما ادري هذه كشف فشله اول مره اسمع بها. طيب شباب, we will see how to do that with MATLAB. Just one comment and we will see how we can do that. A little bit of concentration if you don't mind, and we go to the next slide. هنا شباب, we have this equation. We wrote our equation in this form. We wrote it 1 plus JS h of s for unity feedback. The characteristic equation will be 1 plus JS h of s or 1 plus k JS. K is okay هنا. We are taking the general case. لأنه k will be built inside HS. فما في مشكلة ناخذها in this one. Now شباب, if we take this equation, the characteristic equation, can we say G of S, GS h of s is equal to minus 1? Yes. GS of h can be minus 1. Now, what is the magnitude of GS h of s? لأنه عندنا two conditions هنا. The magnitude condition, if you take this, magnitude condition will be the magnitude of this one. What is the magnitude of minus 1? Here 1. So the magnitude condition will be GS h of s. متى الانجل will be equal to minus 1. يعني هنا. يعني when we have this case, minus 1 plus j0. Minus 1 plus j0 when we have pi. When we have هنا 3 pi. When we have 5 pi. When we have 7 pi. All this condition will satisfy minus 1 plus g0, which is the angle condition هنا. The angle condition will be minus 1 plus g0, which is pi plus or minus 2L pi. يعني the condition will be plus or minus 2L plus 1 pi. والmagnitude condition, this should be equal to 1. فهذه two conditions. If these two conditions are satisfied, we will see how to plot the root locus now. Remember, here we assume that GS h of s is a ratio of a polynomial in S, like we did. Since GS of HS is a complex quantity, so equation 6 can be split into two equations. Equation giving you the angle and the equation giving you the magnitude. So the angle condition will be -1. In an angle of this will be the angle of this, when this one will be -1 when we have pi plus or minus 2L pi. The magnitude of this one will be 1. So if these two conditions are satisfied, these are the rule that we are going to follow. The root locus starts at the open loop when k is equal to 0. The open loop ends at the open loop 0 when k is equal to infinity. The root locus is composed of n branches. The branches is the number of poles, how many poles you have, how many branches. The root locus is symmetric with respect to the real axis. This is the real axis. If this one does this, this one also will do this, symmetric. If this one does this, this one will do this one, symmetric with respect to the real axis. This is what it means. The root locus can exist on the real axis only on the left of an odd number of real pole and 0, singularity. I will explain this one, Shabab. I will explain this one, left of odd number. We take here now singularities. This is the real axis. This is the imaginary axis. Here we have 1, 2, 3, 4, 5. Here, this is the number of poles. Here we are dealing with number of poles, not the value, Shabab, the number of poles. So this is singularity number 1. This is singularity number 2. This is singularity number 3. This is singularity number 4. And this is singularity number 5. So we are saying the root locus exists on the real axis only on the left of an odd number. This is odd number. This is 1. So root locus exists from here to here. This one too, ما فيه root locus من هنا. This is root locus. So it exists from here to here. This is 4. It does not exist. So this is 5. It exists. So it exists on the left of an odd number. عدد فردي. عدد زوجي أو فردي. So فردي is here. This is number 1. This is number 2. Nothing. This is number 3. ما نقول على القيمة يا شباب. We are not talking about the value. We are talking about the number of an odd number. So the angle of asymptote, we will take them to be 2L plus 1 multiplied by pi divided by number of pole, number of 0. Number of pole, if we have 2 poles, we'll say NP is equal to 2. If we have number of 0, we'll say NZ is equal to 0. Intersection of the asymptote, it will be sigma. الاسيمبتوت هنا هو خط مقارب شباب. في بعض الأحيان الروت locus will do this. جاي من هنا, it's coming from here and it's doing this one. And then it does this. It goes هنا مقارب. It will be parallel to the asymptote. في الانفينيتي it will be parallel to asymptote. It will be, we will see it now step by step. So the intersection of the asymptote will be sigma, summation of pole minus summation of zeros over number of pole minus number of zeros. And then we will do the Routh-Hurwitz test to produce information about the intersection with the imaginary axis. We will see here if there is intersection, ولا لا. And then we will see the necessary condition for the breakaway point. So the root locus is coming from here, and then we will see when it is breaking, when it does the breaking. D over ds, gs h of s is equal to 0. All this, you will have them in your final exam. It will be included. But you will have this as a rule to follow step by step. And we will solve 2 examples for you step by step. And then we can do the root locus just by using MATLAB common. You have the numerator, you have the denominator, and then you have R locus. If you just type R locus, it will give you numerator and denominator. If you want to see what is the value of the K and the pole, you just like R log find numerator and denominator. This, of course, for smart people الشباب الشطار جيين الشطار it will help them a lot في final exam if they use this because it will give you straight away the answer. أنا نحكي لكم على الأسرار تاع الفاينل exam. I should not tell you normally, but this one help you a lot to find the root locus. So شباب, if you want to sketch now, sketch by hand the root locus RL where K is positive for a system whose open loop transfer function is given by JSH of S. JSH of H of S is given by this one, K over this one, or this one. So use MATLAB to sketch the root locus, compare the two sketches. هنا poles usually we put them as شباب هنا if we draw the poles on the imaginary axis or the S plane, we have this one. Always we put X for the poles. X for the poles. S is equal -1 هنا. S is equal to -1. S is equal to -3 and S is equal to -4. We put them هنا. S is equal to -1. S is equal to -3 and S is equal to -4. S is equal to -4. واضح شباب? These are the poles. We put them هنا. For real axis, imaginary axis. So therefore the number of poles NP is equal to 3. How many poles do we have? 3. So NP will be equal to 3. How many zeros do we have? NZ will be equal to 0. ما عندنا zeros. So NP is 3 and Z is equal to 0. ما عندنا zeros هنا. So the root loci on the real axis are to the left of an odd number of finite pole and zeros. Let's see now. I will change the color, شباب, just to change the color to show you where the root locus is located. This is the first singularity. So the root locus will be located from here. يمشي من هنا. So هنا we are seeing هنا and then there is no root locus from here and there is root locus from here. لأنه قلنا of an odd singularity. First singularity, second singularity, third singularity. So the root locus is located from here. يجي من هنا بعدين يزيد يروح من هنا. So هنا شباب we have K at this one we have K is equal to 0. We have K is equal to 0. We have K is equal to 0 لأنه قلنا the NP is equal to 3. There are 3 branches, each start at K is equal to 0 and ends at K is equal to infinity. So here it is at 0, but it goes somewhere to infinity. We will see where it goes to this somewhere to infinity. Now we will see the asymptote. لأنه since it is at 0 and it goes to infinity, for sure there is an asymptote. This asymptote is كيف نحسبها؟ نحسبها كده. Sigma will be summation of pole minus summation of zeros minus number of pole minus number of zeros. Summation of pole minus summation. If you sum up your poles شباب, can you واحد يجمع لنا البولز كم؟ minus 1 minus 3 and then minus 4. كم هذه تعطي شباب؟
minus 8.
طيب عليك نور. minus 8 they'll give you minus 8 minus total of zeros. ما عندنا zeros. minus 8 minus 0 will be number of pole minus number of zeros. يعني at the end of the day we will have minus 3 minus 8 over 3 minus 8 over 3 تعطيك minus 2.667. واضح شباب؟ So minus 2.667 إذا كان هنا minus 1 وهذا minus 3 minus 2.667 is somewhere هنا. واضح شباب؟ So this is sigma, the value of sigma. I'm drawing هنا a normal line or ممكن أغير. If you give me just I will repeat the drawing حتى توضح sigma. This is real axis minus 1 minus 2 minus 3 and then minus 4. هو minus 2 هذا في الحقيقة مش موجود ما عندنا بس عندنا minus 2.667 قلنا this is sigma. Sigma is here. This is sigma. Real value. So the real value هنا is minus 667. Now we will see the asymptote. الاسيمبتوت شباب, if you remember, الاسيمبتوت قلنا نحسبها like this. Theta will be equal to 2L plus 1 2L plus 1 times pi divided by n pi minus nz. Okay, 2L plus 1 pi and pi minus nz. Let's take L is equal to 0, shabab. Theta when L is equal to 0. Here, this equation, it will be 2L plus 1 times pi divided by np minus n pi is 3. np minus nz is 3. So when L is equal to 0, L is equal to 0, what will be theta هنا شباب? Pi over 3, صح? Theta will be pi over 3. And L is equal to 0. If you substitute L is equal to 0, you will find pi over 3. So theta will be pi over 3. Now let's take L is equal to 1. L is equal to 1. It will be 3 pi over 3. 3 pi over 3 يعني theta كم تصبح؟ 180 درجة أو pi. If now if say L is equal to L, we took 1, we took 2. L equal to 0, 1, 2. This one will be how much? 5 pi over 3. 5 pi over 3 اللي هي you can take it pi minus 60 it will be, or minus pi يعني minus 60. 5 pi over 3 or minus 60. 5 pi over 3 or minus 60. Minus 60 degree. Now L is equal to 3. L is equal to 3 تعطيك 7 pi over 3. 7 pi over 3 هي نفسها 60 درجة. 60 يعني repeated as the first one, pi over 3. If it is repeated, I will stop. في واحد ما هو فاهم how did we find pi? We are using this القانون هذا. Theta is equal to 2L plus 1 pi over n pi minus nz, we found it to be 3. We are varying L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3. ولقينا 3 angles. لقينا pi over 3, لقينا pi, ولقينا minus 60, ولقينا 60. Since this one is repeated, I will stop here. I will stop. يعني I will have 3 angles. Theta is equal to pi over 3, theta is equal to pi, and theta is equal to minus pi over 3. فشباب هنا, this is the sigma. From here, I will draw my asymptote like this. Asymptote like this and asymptote like this. 60 درجة وماينس 60 درجة, وعندي 180 درجة اللي هي هذه. 180 درجة, it will be here. This one. So these are my asymptote. Now, root locus is coming from minus 1 from here, and then it will go k infinity, it will go asymptote هنا, k infinity. And then it's coming minus 3 هنا, as you can see, عندي minus 3, it goes to infinity from here. هنا ما هي واضحة الآخر, بس I will show you next slide. We found the angles. We found the angle here, 60, 180 minus 60, stop here because it is repeat. Now we will see the breakaway point. What is the breakaway point? The breakaway point, قلنا we found asymptotes. These are the asymptote, here and here. This is sigma is minus 2.6. Asymptote هنا is 60 degree. And here is minus 60 degree. The pole is coming from here. So we will see now the breakaway point. كيف راح يسوي كده? We'll say this point here. We are looking for this point. This point, how to find it? Just take this, dk over ds. When you take dk over ds, you have this equation. You get it from the original equation, from the characteristic equation. This will give you this equation. K times all of this. Now we found 3 when we solve this equation equal to 0. When we solve this equation equal to 0, so we have 2 poles, minus 3.5 and minus 1.78. Minus 3.5 is not part of the root locus because it's not from here to here. It should be from here to here. It's not. So this one will be discarded, and we take only this one. Now, if we see the root locus, I will show you the root locus, what we did. This one. Here, S is equal to -1. This is what we found. Here, we found S is equal to -3, the poles. Here, S is equal to -4. We found S is equal -2667 here at this value. The asymptote is here. The asymptote here means that the root locus will be parallel to this line with angle 60 degree. The root locus is coming from here, and it's making now it's this way, going in this direction. And now it's coming also from here, and it's going this direction, the green one. And the breakaway point, we found it to be -1.67. We excluded the value of -3.5, and -3.5 is not part of the root locus. When the root locus is just on the left of odd singularity. This is first singularity, this is second singularity, this is third singularity. So this one is not part, -3.5 is not part of the root locus. Now we found this, Shabab. If you take a picture of this one, I will go back to the previous slide. Here, this is what we did. This is what we say about it. -1.5 is a part of the root locus, and the breakaway point, I'm talking about this point, -1.7558 is this one. Here. This one, breakaway point, which is minus. So at this point, root locus ikun J at S is equal to -1, this way to the left, until it reaches this one, and then it goes like this. Here it make a tangent, which is like this. This is tangent, as you can see. I don't know, my pen is not really. This is the tangent. So it's like this. So this is a breakaway point, and it goes parallel to the line 60 degrees, We call it asymptotic line. So this is, we found it, the breakaway point. We need to find, Shabab, hina, the intersection with the y-axis. The intersection with the y-axis or with the imaginary axis, it's giving you this. We need to solve this equation. Either we solve this, or either we form the Roth array. If we form the Roth array, we will do this way, Shabab. The intersection with the imaginary axis, manatul poles are pure imaginary. When the poles are pure imaginary, you remember we said this case can open when we have the poles located like this or like this. We will have a row of zeros. This row of zeros, we can get it from here. If we form now the Roth array from the characteristic equation, if you write the characteristic equation, this will be the Roth array. This can be 0 when k is equal to 140. If k is equal to 140, this will be 0 and this will be 0. And in this case, if this is a row of zeros, you will formulate your auxiliary equation. The auxiliary equation here, it will be simply 8s squared plus 12 plus k equal to 0. Of course, in al-k gulna, this one will be valid or will be 0 only if k is equal to 140, as you can see. So this will give you omega is equal to 4.36 plus or minus omega 4.36 radian per second. This will happen, so the value for which the imaginary axis or the root locus crosses the imaginary axis is when omega is equal to 4.36 radian per second, which is this one here. At this value, we will have omega is equal to 4.36, and k at this value will be equal to 430. باقي شباب, you can find this value just by taking the characteristic equation 1 plus k gsh of s, which is this one, and substitute s is equal to j omega. If you substitute s is equal to j omega, when it crosses the imaginary axis S will be equal to J omega. If you just substitute by S is equal to J omega, you will get two equations. One is the real part, and the other one is the imaginary part. So the real part will be equal to 0, and the imaginary part will be equal to 0. If you solve this, the imaginary part is equal to 0 and the real part equal to 0, it will give you omega is equal to square root of 19 or 4.3589, which is exactly 4.36 radian per second. You substitute here, omega is equal to 4.36, you will find K is equal to 140, exactly like we did. So if we summarize what we have done so far, this will give you 140. You can do this one with MATLAB, of course, and you will find it. Just apply this one, and this is your root locus. Now, by looking at here, you will see that your system is stable on this region, the left-hand side, and K should not be greater than 140. So your system should be less than 140 to have stable system. If K goes beyond 140, you will have a non-stable system. Of course, here you have to be careful here, and after that, maybe somewhere here, K will be 140, and K from here to here goes to infinity. Somewhere K is equal to 140. Don't go beyond this. Don't say, oh, I am in the left-hand side, so my system will be stable. لا. لأنه you are restricted by this K. K هنا should not be more than 140. هنا, this is one branch. The red one is one branch. The green one is one branch. And the blue one is one branch. And we have 3 branches of the root locus. This goes from 0 to infinity. This goes from 0 to infinity. And this goes from 0 to infinity. We will solve, inshallah, 2 more problems in next lecture. And I hope this one is in. I will stop here. Sorry, I took more time than I should. But unfortunately, I needed to explain this one. Cannot stop it at the middle. شكرا على حسن الانتباه، وخلوني بس اخذ ان شاء الله الاتندنس نعم
فري اليوم الاتندنس، هديه
فخلص فري. اوكي خلاص ما في مشكله. اوكي جو هيد. يلا شباب
دكتور ما تحذف واحد من الاتندنس.
يعطيك العافيه. يلا دكتور،
هاف نايس ويكند. ادعونا بس.
دكتور بسألك سؤال.
اللي عنده ستيل عنده استفسار على الامتحان he can send me email and we can discuss this. he can send me email في الويكند ونسوي موعد and we can discuss it. أي واحد عنده إشكالية في الامتحان send me email, we will make appointment, we will discuss it. خلاص؟
تمام. دكتور بخصوص الغياب، في غياب مجاني ولا تنحسب من أول غياب؟
اليوم ما في غياب.
لا بس أتكلم عن الماضي، يعني مثلا واحد عنده غيابين.
محمد عبده يقول لك من بادي الوقت وهذا طبع الأيام. أثبات الأيام لا تمضي لياليها، حلوة الليالي توارى مثل الأحلام، سريع الأيام.
شاعر يا دكتور، ما شاء الله عليك.
يلا شباب نشوفكم إن شاء الله.